from this, we are going to generate the expression for carry. How to make? See here, if you see C1, say for example, here we have seen Ci plus 1 equal to Gi plus Pi and Ci. Do you remember this? Here we got no Ci plus 1 equal to this one only I have taken now. I am going to concentrate only on the carry now. So Ci plus 1 equal to Gi plus Pi Ci. So from this I am going to generate the expressions. Okay. So now same thing I have written Ci plus 1 equal to Gi plus Pi Ci. Now you substitute I equal to 0. If you substitute I equal to 0, what I will be getting here? C1 equal to, okay, I value is what? 0, right? So G0 plus P0 C0. So I got the expression for C1, the first carry out. Okay, I got the expression for C1. Now what I have to do? Now I am going to assign I value equal to 1. If I am putting I value equal to 1, what expression I will be getting? I value is 1. So 1 plus 1 is 2. So C2 equal to, here I value is 1, right? G1 plus what I will be getting? P1 C1. What I said, how I got C2? C2 equal to, I mean I am putting I value is 1 now. So 1 plus 1 is 2. C2 equal to, here Gi means G1 and PICI means P1 C1. So here it is. Okay. Now what I am going to do is, I know the expression for C1, right? I know the expression for C1. So now I am going to apply it here. See here you can see G1, P1 and I know the expression for C1. So what is C1? G0 plus P0 C0. Okay. Now in the place of C1 I am going to apply this. And then what I will be getting? G1, P1, G0. See here you need to multiply this. G1, okay. And then P1 into G0 and then P1 into P0 C0. Okay. So now I got the value for C2. Okay. This is the expression for C2. Okay. Similar way, I'm going to put I value is what? 2. So when I value equal to 2, what will be the expression? Ci plus 1 means C3. Okay. C3 equal to Gi, that is G2 plus PICI, no? So P2 C2. Okay. So in this expression again, what value I know? I know about C2, right? Just now we calculated C2. So in this place, I'll be applying this expression. So if I apply that, I'll be getting this one. Okay. So inside you need to multiply, then I'll get G2, P2 like this. Similarly, when my I value is 3, what I'll be getting? C4 equal to G3 plus P3 C3. Now again, I know the value for C3. So I'll be applying it here. And if I do the product, I'll be getting this. Okay. So from this, very simple only. If you know the concept, you can directly write it on your own. Okay. By applying this, we will be calculating all the carries. Okay. And one more thing. If you see the expression C1, C2, C3 and C4, what is common everywhere? C0 is common to all. Okay, so P0 is also there, but here we are concentrating on the carry C0. So if you see all the expression, all are written in terms of C0. Okay, that means from this what we can suggest, where the C0 will come, like first location I am adding means to the first location the carry comes in is C0, right, to the first bit location. So when I am getting the C0 value only, if I know the first carry input itself, I can calculate all remaining carries. Okay, you can see here. Everywhere I am having only C0. So in such a way that we have written the expression. Okay. So if I know the carry input for the very first gate, this is C0, no? Very first bit. If I know this itself, automatically with the help of the expression, I can calculate this, this, and also this. Okay, at the very first stage itself, when I am getting know about C0, I can calculate all remaining carries. Okay, if I apply the clock pulse, what will happen? So, this gate will give me the sum, and then for this gate also I got the carry now, right? So this will also will give the sum, this will also give the sum, and here the next also will give the sum at the same time. So here there is no delay at all. Why? Because at the beginning itself I am calculating the carry in advance. That is why it is called carry look ahead adder. At the first beginning itself I will be calculating the carry. So this is how the carry look ahead adder will work. Very simple. How to derive the expression? First, I have to write the, I have to introduce two signals. One is propagate, another one is generate. So propagate will just pass the carry to the next stage, and generate, what it will do? It will generate the carry. Okay, when it will generate the carry, there are two possibilities. One is when both are 1, or when any one is 1 and the carry input is 1. In that case, it will generate the carry. And from this, we first written PA equal to and GA equal to. After that, we have written sum and carry in terms of P and G. So here you can see. So first we have written PA equal to this, and GA is this one. And then now sum equal to what? PI XOR CI. Okay, from the diagram we have written this, and carry also we have written from the diagram. Okay, so this is important. With this only we are proceeding. CI plus 1 equal to GI plus, carry generated plus PI and CI. Okay, now what we have done here, first we applied I value was 0, then we got G0 plus P0 C0. Okay, so we got the expression for C1. Then again for C2, when I value equal to 1, we got C2 value. So in the place of C0, we applied. So here, right, in the place of C1, we applied this. Okay, like that, we have derived all C4. Stage, we got the expression. Then what should be the next stage? We have to draw the diagram. All this expression, right? So first, C1 equal to G0 plus P0 C0. So here if you see, C0 is common. See, while drawing, how to remember, I'll tell you. So C0 is common, no? So you put one straight line. It's going till last gate. Okay, C0 is common. Common to all. Okay. And here, when you take C1, what are the input? G0. G0 is what? AI and BI, no? This is G0. Do you remember? A0 and B0. That and all we will expand further. First, we will see only the carry circuit. First, we will see the carry circuit. Then we will expand the remaining things and all. Attachments and all we will give further. Okay, first, when you see C1, what is the expression? So, G0. So, G0 will come directly. And then plus means I will be using one X. OR gate, right? Plus means OR gate. And what will be the another input? Another input will be P0 and C0, I'll be putting one AND gate. It's product, no? Understood this part. Same thing here it is done. Okay, so G0 is going, and then for this one, I mean this is P0 and C0, no? So P0 is coming and direct C0 is there, no? Directly it is taking. Okay. So this is P0 and C0, and here directly this is what? G0, which gives C1. Similarly, when you see the next stage, what is given? Okay, next stage, what is given? G1. So G in OR gate, right? Plus means OR gate. So the G1 is coming here. Okay, this is G1. And next is what? P1 and G0. So P1 is coming here. And here if you see, this is G0. Okay. So P1, G0 here AND gate. So AND gate is there. And this also connected with this OR gate. And the next is P1, P0, C0. So you can see here, this is what? P0. And this is what? P1. And then C0. So C0 is going here, no? So this is C0. So they have connected everything and this is coming to this. Can you able to understand the diagram? It's very simple. Step by step you can proceed further. Okay, if in board means I can draw it and show you. So here you please try to understand what is given. Here first OR gate you see. OR gate, what are the terms are coming? G1, directly G1 will come. And next term is P1 and G0 is already there. This AND gate. And for next AND gate, 3 inputs. What are the input? P1, P0 and C0. So finally, if you put OR gate, you will get C2. Similarly, for C3, you connect these things. Okay, you will get C3. Any doubt in making this circuit, ma? Otherwise, I can repeat once again. Is this clear? How to make the carry?
Yes, ma'am.
Okay. Now, what they are doing is, in lab also you can do the same thing. See, in lab you will be forming the circuit and all. It will be very interesting. Lively we will be doing this. So here, for this, what they will do is, they will make this circuit and they will make it as a IC chip. In lab also we can make it as a chip, IC chip. So that wherever we want, we can use it. Okay. So here, the IC number also you can remember. This 4-bit adder, the carries are made it as a single chip. Okay, the chip number is, IC number is 74182. Maybe an MCQ question. Okay, so what they will do is, after forming this, they will make, after forming this circuit, they will make it as a single chip. See here, I am not bothering about C4. Why I am not bothering about C4? This is 4-bit adder. Okay, for 4-bit adder, if you see, okay, for 4-bit adder, 1 minute. Okay, for 4-bit adder, what are the carries we need to concentrate? C0, C1, C2 and C3. Do you need to concentrate about C4? No need. Why? Because it's going to next stage. If you use 8-bit adder, then we need to concentrate on C4. So you no need to construct the circuit for carry 4. Okay. Only we need the circuit for C0, C1, C2 and C3. For C0, there is no circuit, direct input only. So we have to concentrate only for C1, C2 and C3 for 4-bit adder. Okay. If it is going to be 8-bit adder, then remaining carries also we need to construct the circuit. But since we are using 4-bit adder, we can stop with C3. Okay, while constructing the circuit. So that is why here we stop with C3. Okay, since it is 4-bit adder. Okay, now we got this IC, right? So now this is the IC. Okay, So the IC is having all this carries. Okay, IC means it is an integrated chip. Okay, whatever circuit we made, that is inside that IC. Okay, so now what are the things are there in IC? C1 we calculated, C2 we calculated, C3 we calculated, and C4 is there. Okay, all are there inside the IC. And what more input we need to give? So there we have seen, no, what are the inputs we need for this circuit? You can see C0, G0, P0, G1, P1. These are the input to this board. No, so here we made this as a chip. Okay, you just visualize. Now we made this as a chip. The outputs are C3, C2, and C1. Okay, and what will be the input for this circuit, for this chip? These are the input for this chip. Okay, how to give that input? So now, what is P0? A0, B0, XR. Am I right? That is P0. And what is G0? A0 and B0 is G0. Do you remember? In very first diagram we have seen, no, this is what circuit actually? This is half adder. Do you remember? This is half adder. From this only we had PI and GI. So how to make PI? A XOR B is Pi. That is here I value is 0 means P0. And G0 is A0 and B0 ANDing. So this is G0. So these are the input for this. Again for P1 and G1, what will be the input? A1 B1 XOR is P1 and A1 B1 AND gate is G1. We are having the carry. Okay, now in input we are having C0 also. Now we will see about this. What is this? Sum. We calculated the carry. How the sum are calculated? Si equal to Pi XOR Ci. So for example, S0 equal to P0 XOR C0. Okay. Example S1 equal to P1 XOR C1. Okay. So with this knowledge, we will draw it there. Okay. Now, what is S0? I said P0 XOR C0, right? So here we got the output. Now, so this is C0. Okay, so this is C0, and from here internally you will get P0 here. Okay, so C0 and P0 XOR gate will gives you the sum 0. For sum 1, what we have to do? Sum 1 equal to, so P1 XOR C1. So P1 is here we calculated. No, it will come P1 XOR C1. C1 also we generated. No, C1, C2, everything we generated. So it here we'll get sum 1. And for sum 2, P2 XOR C2. So P2 XOR C2. And for sum 3, P3 XOR C3. And the carry out is C4. From this, whatever carry is coming, directly that will come as C4. Okay. So this is how we need to make 4-bit parallel carry adder. So carry will be generated at the initial stage itself. So this is the use of carry look ahead adder. So the first stage is you draw the full adder circuit. From full adder circuit, you just introduce two terms, propagate and generate. Propagate means it will just, whatever carry is coming, it will just pass it. That is propagate. Okay. And I'll tell you, okay, how the propagate is working. I didn't tell you, no. I'll tell you. Say, for example, if both the inputs are 1 and 0. For example, this is my scenario. For example, A is 1 and B is 0 and C is this 1. Okay, so if I'm applying in XOR gate, 1 and 0 will be 1, right? Okay, now here what is coming? 1 is coming. Generator is going. What is the generator here? What is the generator here? If 1 and 0 is there means generator value will be 0. So the 0 will come here. Okay. So in this case, when it goes out to the OR gate, the output will be 1. Okay. What the propagator is doing, whatever the carry input, the same thing is coming as a output. That is the use of propagator. So propagate means it will just pass the carry to the next stage. So whatever in C in, same thing will be the C out. You don't confuse too much. Whatever in C in, that will be going as C out. That is the use of propagate. Just pass the carry. What is the use of generator? That itself will generate the carry. For example, if both are 1, it will generate the carry 1. Okay. So, based on this, we have to make P1 and PI and GI. After that, based on this PI and GI, we have to write the sum and carry expression. Okay. In this, we have to concentrate only on carry. So, when you write about the carry, C1 equal to G0 plus P0 C0. So from this, what we have to do? Next step is C2. That is I value equal to 1. If you put, I will get C2. So in C2, what is the expression? G1 plus P1 C1. So here I know the value for C1. You just apply this expression here and you will get this one. And similarly for C3, I know the expression for C2. Apply this expression here and you will get this one. And for C4, I know the value for C3. So apply this expression, I will get this big one. After that, what I have to do? I need to draw the circuit. So you don't need to draw all these things. Okay, you just simply skip it. Directly you can come here and whatever expression we got, from this expression we need to draw the circuit for carry alone. So this carry will be made it as a chip. Okay, after making the circuit, you put it in one chip. After putting that, the next stage is for that particular chip. I mean, for this particular chip, I need to give some set of input and I need to take set of output. How to do that? That only it's given here. What are the inputs I need to give? P0, G0. So how P0 is calculated? A0 XOR P0 from the beginning expression. And G0 is this. Similarly, I have to connect everything. So here I am having 4 half adders. All are half adders, no? 4 half adders I am having. And here this side output, I need to take the sum output. How to take sum output? S0 equal to P0 XOR C0. That's it.